Hi friends, today I am going to discuss about the graphs and simple graphs. I am Sahai Roslan, Associate Professor, Department of Mathematics, Vishavar College, Trichy. Graphs. First we discuss about the graph. Graph is an ordered triple V of g, E of g, psi g consisting of a non-empty V of g of vertices, a set E of g disjoint from V of g of edges and an instance function psi g that associates with each edge of g an unordered pair of vertices of g. Here we have an ordered triple. V of g is a set of vertices, E of g is a set of edges, psi g is the instance function. And this is the example for a graph. Here we have a graph G with vertex sets consisting of 5 vertices, edge set consisting of 8 edges, and psi g is defined as psi g of E1 is V1 to V2, psi g of E2 is V2 to V3, psi g of E3 is V3 to V3, psi g of E4 is V3 V4, psi g of E5 V2 V4, psi g of E6 V4 V5, psi g of E7 V2 V5, psi g of E8 V2 V5. And here we have the graph like this, and this is nothing but the edge E3 denotes a loop and edges between V2 and V5 represents parallel edges. Other edges are normal edges. And now we are going to see some simple graphs. And here we have we are considering 6 types of simple graphs: null graph, trivial graph, non-trivial graph, simple graph, finite graph, planar graph. Here null graph is nothing but a graph if its edge set is empty. That means we have only vertex sets. There is no edge. Coming to trivial graph, it is nothing but a graph with just one vertex where we don't have any restriction for edges. We have only one vertex. That means there is no edge. Only one vertex means we can call that graph as trivial graph. A graph with more than one vertex is called non-trivial graph. Here there is no restriction of edges. We have more than one edge also. Here we have some examples for null graph. Here only vertex sets. There are no edges, therefore we can call this graph as null graph. And here this is a trivial graph because it contains only single vertex. And this graph is nothing but non-trivial, it contains more than one vertex. And next, simple graph. The name itself, it is simple. That means the graph has no loops, no two of its links join the same pair of vertices. That means no parallel edges. Then we can call that type of graph as simple graph. Coming to finite graph, the name itself, we have finite. Therefore, both vertex set and edge set must be finite. If it is finite means we can call that type of graph as finite graph. Next, planar graph. Graphs that have a diagram whose edges intersect only at their ends are called planar graph. That means there is no intersection of edges. This is an example. And this graph here, the graph A contains no loop, no parallel edges. Coming to graph B, there are no parallel edges, there are no loops also. So therefore we can call these two graphs as simple graphs. And also edge set and that is edge set as well as vertex set, both are finite, therefore both the graphs are finite also. And it also planar graph because we can have, if the first graph can be drawn in such a way that no two of its edges intersect, or you can say without the intersection of edges we can draw the graph. Therefore we can say this is a planar embedding of this graph G. Thank you.